Hello everyone, my name is Kirti. Today I am telling about topic is interference in thin film by reflection. We have to see the definition of interference in thin film by reflection. Interference in thin film is due to superposition of light reflected from the top and bottom surface of the thin film. What is interference? Interference is a superposition of two or more light waves producing a dark and bright fringes. This is the total. Now let us consider a thin film whose thickness is T with refractive index is mu. Let a monochromatic light ray AB incident at an angle of incidence of I on the upper surface of the film. This ray is partly reflected along BE and refracted transmitted along BC. With an angle of refraction, or the ray BC will be again reflected and energized out through the thin film is DF. These two light rays superimpose and depending upon path difference between them, they produce interference pattern. Now we have to see the diagram. Now see AB ray reflected refracted as BC and BC ray again will be energies throughout the CF. We have to find the path difference between DF and GE. To know that the path difference, let us draw a normal DG to BE. DG to BE from points D and G, the light travels equal distance. By the time the reflected light travels from B to G, the transmitted light has to travel from B to C and C to D. Therefore, the path difference between the light rays BE and DF, this path difference is equals to the refractive index mu is refractive index into BC plus CD in thin film by minus BG in air. That is in equation 1. Now we have to find BC and BC plus CD. That's why we have considered from triangle BCH cos R is equals to HC by BC. We know that HC is a thickness of film, that is T. Cos R is equals to T by BC. BC is equals to T by cos R. That is equation 2. Similarly, from triangle HCD, cos R is equals to HD by CD. Cos R is equals to T by CD. CD is equals to T by cos R. That is equation 3. Now adding equation 2 and 3, we get the BC plus CD, that is 2T cos R. This is equation 4. Now to calculate BG, let us consider a triangle BGD. From triangle BGD, sin I is equals to BG by BD. BG is equals to BD sin I. BG is equals to BH plus HD into sin I. That is equation 5. To calculate BH and HD, consider from triangle BCH, tan R is equals to BH by HC. Tan R is equals to BH by T. We know that HC is equals to T. BH is equals to tan R. Similarly, from triangle DCH, tan R is equals to HD by HC. That is HD is equals to T tan R. Adding equation 6 and 7, we get BH plus HD, that is 2T tan R. That is equation 8. From Snell's law, we know that mu is equals to sin I by sin R. Sin I is equals to mu sin R. Substitute equation 8 and 9 in equation 5. That is BG is equals to 2T tan R mu sin R. 2 mu T tan, we have to write that sin by cos. Sin R by cos R, that into sin R. 2 mu T sin into sin square R divided by cos R. Substitute equation 4 and 10 in equation 1, that is path difference is equals to mu into 2t by cos r minus 2 mu t sin square by cos r. 2 mu t by cos r is common. The remaining that 1 minus sin square or 2 mu t cos r 1 minus sin square, that is this cos square, or we know that sin square plus cos square is equals to 1. 1 minus sin square r is equals to cos square. Path difference is equals to 2 mu t cos r, that is delta is equals to 2 mu t cos r. But at point reflection is from denser medium, so there will be addition phase change of pi or path difference of lambda by 2. The total path difference is equals to 2 mu t cos r plus lambda by 2. Now we have to see the conditions. Condition for constructive interference. To observe constructive interference, path difference delta is equals to n lambda, but we have delta is equals to 2 mu t cos r plus lambda by 2. By equating this two equation, we get 2 mu t cos r is equals to 2n minus 1 into lambda by 2, where n is equals to 1, 2, 3 and so on. Condition for destructive interference. To observe destructive interference, path difference delta is equals to 2n plus 1 into lambda by 2. We have delta is equals to 2 mu t cos r plus lambda by 2. By equating, we get 2 mu t cos r plus lambda by 2. 2 mu t cos r is equals to n lambda, where n is equals to 1, 2, 3. These are the conditions